GM, what's up, clovers? In today's video, what we're going to understand is how do we stake an NFT and generate some tokens for that staking. This is a very common request in my Discord server and my YouTube channel comments. So finally, I'm picking this today. We are going to implement a very basic NFT staking contract today, and based on what kind of feedback I receive, based on how you like this video or not, based on you hitting the like button on this video, I will see if we have to do a more advanced version of this. In today's video, what we're going to finally see is how do we stake an NFT to a certain smart contract, then that smart contract generates tokens based on the time that NFT was staked. But before we get started, please make sure to hit that like button, subscribe to this channel if you haven't. If you have any questions, if you have any message for me, please leave it in the YouTube comments. I try to read all of the comments that I get, and if you have any specific question, come join my Discord server. There are a bunch of people just like you and me who are willing to help each other out. The link is in the description. Alright, with that said, let's get started. So roughly speaking, these are the four things that we need to do. We need to create the NFT smart contract, create a token, ERC20 token smart contract. We have to add the on ERC721 received method to that token, and we need to store the timestamps during which the NFT was staked and unstaked, because based on that we will generate some tokens and give it to the user. We'll also add a method which just shows how much currently the staked NFT would have received in terms of tokens, so that the user can then just check that this is the amount that I can possibly gain if I just unstake my NFTs. Alright, so let's just get started with this. The first thing that we need to do is, of course, open Zeppelin, right? The Open Zeppelin wizard. Let's select the ERC721 over here and just write my NFT NFT over here. Let's make our NFTs mintable, and we don't really need anything else, but if you want to use something, just go ahead and use it. Now I will open it in Remix. Remix, if you don't know, is an amazing IDE provided by the Ethereum Foundation. So we have our first contract, my NFT contract over here. Let me just rename this just so it is easier for everyone to read. Alright, so my NFT.sol is already here. The another thing that we need is the token smart contract. So I go back to Open Zeppelin wizard and then select ERC20. Let the name be my token, it's fine. Symbol is MTK. I also need a feature which basically says that the token is mintable. Rest of the things you can do if you need to, and if you don't need to, just leave it as it is. Okay, once I'm happy with this, I'm just going to copy this to clipboard, go back to Remix and click on this button. This will create a new file, and I'll just write it my token.sol and then paste the code, the my token code over here. Now what you can see is that there is no pre-mint here, and only the owner can mint these tokens. So what we actually need to do is only people who are staking or unstaking are allowed to mint this NFT, alright, this token, sorry. What I'm going to do is I'm just going to comment this for now, and then we'll come back. What will be the flow of this? The first thing that we will deploy is the NFT, alright, and why is that? Because once we deploy the NFT, we will get the address, and then we can just pass that address to my token, so my token knows that this is the NFT that I have to use to stake or unstake things. So I've already compiled this, and I'm going to go here and select my NFT.sol and click on deploy. So once that NFT is deployed, we are good to go. You can see that there are a bunch of methods over here, and only the owner is allowed to mint. So we can actually go ahead and change these things. We can also add like automatic index increment. To do that, just write UN256 public total supply, and what we can do is we can remove the token ID from here, and then what we can do is total supply plus plus, and then just add total supply over here. Alright, so this NFT can be minted by anybody to their own address, and then once they mint this, we will allow them to stake this. Alright, so just let me remove this, make sure that it is compiled again, select the my NFT and click deploy once again. So this time you can see the safe mint only requires the to address. So this is the kind of NFT smart contract that we need. We will not go much deep into this. Of course, if you want to build a more full-fledged smart contract, There are a bunch of other videos on my channel that you can check out. I'll probably link to them somewhere in either the description or on the I button, so just go and check them out first if you want to create a full-fledged NFT smart contract. This for our use case is more than enough. Now we go to mytoken.sol, and if you check out my notes, the earlier notes, you can see that I have written add on ERC721 received to token smart contract. So what is this method and why do we need to implement this? Now if I open EIP 721, which is the standard for 721 ERC721's NFT smart contracts, you will see that there's an interface called ERC721 token receiver that we need to implement if we want a wallet, broker or auction application that receives an NFT. So as you can see in this interface, it writes handle the receipt of an NFT, and we need to basically implement this function, and we need to return signature of this function, this specific function. All right, one thing that we can do is of course go ahead and implement this the way we want to, or OpenZeppelin has done this on our behalf. So now if I open the OpenZeppelin's GitHub repository, there's a contracts folder that I can open, and there's a token and then ERC721 that is present over there. Now there is an interface called IER721 receiver that basically we need to implement, but OpenZeppelin also gives us an implementation directly, which is present in the utils folder, the ERC721 holder.sol. So it is that OpenZeppelin contracts, token, ER721, utils, ER721, holder.sol. So we can simply just implement this by just inheriting this. So instead of even inheriting, I can just directly copy and paste the function over there and it should work. But what I'm going to do is just implement it in a much better way. So what I'm going to do is write import and then copy this ERC20 import. All right. And once I've copied, the next thing that I can look for is just replace the ERC20 with ERC721. All right. So after the token, what we need is ERC721 utils and ERC721 holder.sol. all right, so this is basically importing OpenZeppelin /contracts /token /ERC721 utils ERC721 holder.sol, and then after that I can also just inherit from ERC721 holder in this my token. All right, so this way this my token would implement a function called on ERC721 received, and it will return the correct value that we need. All right, once that is done, the next thing that we need to do is create a stake function. Before we can actually do that, first we need the my token to know what is the address of the NFT contract. So to do that, we will just accept the address in the constructor. We write address and then underscore NFT, and we can also create a new variable public which will be NFT. Here we will write NFT equals underscore NFT. One more thing that we can do which will be better for us is that we wrap this address into an IERC721. Now how do we do that? So we go back to the OpenZeppelin contracts, we go to ERC721 again. There we will see the IERC721.sol. this is the file that we basically need. So this will be token ERC721 and then IERC721. So I'm going to import this this interface file also by just calling IERC721.sol. and once I've done that, instead of calling this address, I can just call IERC721. Now this will give me an error. So what I'm going to do is I'm going to wrap the underscore NFT in an IERC721. So this way we will interpret this underscore NFT as an IERC721 smart contract. So we will get methods like transfer from, safe transfer from directly here. Now let me start writing the stake function. Okay, so the function will be function stake, and then it will basically accept the token ID. It will be an external function, which means only outside users can call this, and then we need to basically fill out the function. So the first thing that we will do is nft.safe transfer from. The from will be from the user, so the user needs to have this token ID in their wallet. Then the to will be the address of this smart contract. The token ID will be token ID. If this succeeds, we need to keep a track of when the token ID arrived and who gave us the token ID. So to do that, we will basically keep a mapping of the token ID and their owner and timestamp. So we can create two mappings, or we can go the struct way. You can decide whatever is easier for you. Since there are only like a couple of variables, I'm going to use two mappings. Using a struct is also fine. So what I'm going to do is I'm going to create a mapping of UN256, and the next thing will be address, which will be token owner of, and another mapping will be UN256 to UN256, and this will be token staked at. So now we have two mappings. The first mapping is who is the owner of this NFT, like who can actually unstake this NFT, and the other is who, at what time the token was staked at. Once the safe transfer form has succeeded, we can just be like token owner of, and then token ID equals msg dot sender, and the another thing will be token staked at. The token ID will be block dot timestamp. So block dot timestamp sort of gives us like a rough time of when the token was staked at. So now what we need to do is basically figure out for how long this token was staked at, and once it is unstaked, we generate that many tokens and give it back to the user who staked their NFT. So let's say we want to emit 50 tokens a day for staking your NFT, and however long the NFT was staked, we will give you tokens proportional to that. All right. So what I'm going to do is just write UN256 public and then emission rate, and this emission rate will be 50 into 10 to the power of decimals divide by 1 days. The emission rate is equal to 50 into 10 to the power decimals, because this is an ERC20 token. So we tell that last 18 digits are decimals, so that that is how we can show it in the UI. But we can't have floats in Solidity, so we use uints for all those things. So 50 tokens generally mean 50 into 10 to the power number of decimals, which will be 18 for our case. But decimals, this is how you basically create 50 tokens, and then 1 days is, I think, 86,400 seconds, which is what it will divide it by. So emission rate is 50 into 10 to the power 18 divided by 86,400. So these many tokens will be released every second to the stakers. Now we need to calculate the tokens that user can claim. Let me just put a UN to token ID over here and make this a public function. This function returns a UN256. Now to figure out this value, what we need to do is block.timestamp minus tokens staked at token ID. So this is the total time that has elapsed. So I'll just store it in a variable. You don't need to do this, like you don't need to store it in a variable. You can put everything in one line, but I'm just going to do this so that it is easier for you to read. So I'm going to store it in a variable called time elapsed. Okay, and then what I'm going to do is multiply this time elapsed by emission rate. The return value will be time elapsed into emission rate. Now we are not storing anything, so we can just change this function into a view function, and now you can see this is how we calculate the tokens that the user has received. All right, so the next thing that we can do is create an unstake function for a specific token ID. All right, this will also be an external function, and this is the function where we mint the tokens mint the ERC20 tokens that we have. What do we need to do in unstake is send the NFT back to the user and mint the tokens. So the first thing that we will do is we will check whether this user was actually the owner of the NFT. So to do that, we just call require token owner of the token ID is actually the message dot sender. You can't unstake if you're not the owner, you are not the original owner. And if you have any other conditions, like you need minimum 7 days of staking, just put them here with a require statement saying that the time elapsed is not 7 days minimum or something like that. Then you need to mint the tokens, the total number of tokens. So to do that, first we calculate the total tokens. and then we directly mint them. To mint, you can see the function over here, so we can just directly call this with underscore mint. To will be message dot sender, and the amount will be calculate tokens with the token ID. This way we are minting the tokens for staking. And the next thing that we need to do is return the NFT back to the user. So to do that, just write NFT dot transfer from. The from here will be address of this. The to will be msg dot sender, and the token ID will be token ID. We also need to delete the mapping that we have stored, so we just write delete token owner of token ID. And another thing that we need to delete is token staked at token ID. Just to make things easier, I'm going to make token owner of and token staked at public, so that we can debug the things that we need to do and get a better understanding of what's going on below these layers. But one thing that you sort of need to understand first is we will not be able to call the safe transfer from before we approve the my token as an approved operator in the NFT smart contract. So once you mint an NFT, you will call a method called approve on your NFT smart contract, and in the operator you will put the token's address so that the token can spend your NFT, transfer it to themselves. This is generally done on front end. So when the user is staking, first the front end makes a call to the NFT smart contract. It checks whether the token smart contract can operate your NFTs from the NFT smart contract. If they can't, the front end opens a request basically and asks you to approve the token as an operator for your NFT smart contract. Once that happens, only then the front end will let you call the my tokens stake function or stake method. Now we have already deployed the my NFT. The next thing that we want to deploy is the my token, and you can see that the deploy function requires an address. So I'm going to copy the my NFT contract address and paste it here and click transact. Once the transaction completes, you can see that there are two contracts over here. One is my NFT, the other is my token. Token is the ERC20, NFT is the ERC721. Now if you open the my NFT smart contract, you will see that there is a get approved, is approved for, set approval for, and these methods that we can use. So one thing that first I need to do is mint a couple of NFTs for myself. So I'm going to paste my address over here and press save mint. Once the NFT has been minted for myself, another thing that I will do is click on set approval for all, and here I will write approved as true, and then I will copy the my token address and paste it here. What I'm doing is I'm going to give the my token smart contract the authority to transfer my NFTs on my behalf. Once I click transact, ERC20 smart contract can send my NFTs to their own address. Alright, once I'm done that, I will have this function called stake where I can enter the token ID 1 and stake this to create some tokens that I will receive after the staking is complete. So I'll click on transact here, and you can see the transaction has succeeded, and it succeeded without any error because I've already approved this token, this smart contract, to transfer my NFTs. This is the most common error that people report to me, ask for a solution in Discord. People generally forget that they have to approve the other smart contract to be an operator, so that this smart contract, this token smart contract, can transfer your NFTs to their own address. Now that I have already staked my NFT, you can check how much tokens I have earned in the meanwhile that I've been talking. So if I press token ID 1 and click calculate tokens, I just realized there was a small bug. Instead of raising 10 to the power 18, I used a caret sign, which is not the correct sign. For 10 to the power 18 or 10 to the power decimal, so whatever, I need to put 2 asterisks. So I've redeployed the smart contract, and I'm going to stake again and click on transact. So this way I've staked. If I try to transact again, this should give me an error. And it gave me an error because I don't own that token ID. Now you can see that there's an emissions rate as well, which basically says these are the number of tokens that I will receive every second. So if I press 1 over here and click calculate tokens, you can see that these are the number of tokens that I have received up till now. I can of course keep clicking this button and it'll update every second to let me know how much tokens I can claim at this point. Now let me just copy my own address and see what is my current balance. So I enter my address and check balance off, and it says it is 0. Of course it is 0 because I haven't unstaked my NFT. So to unstake, I'm just going to press 1 again and press on unstake. So once I have unstaked, you can check out the calculate tokens is giving a random number because I haven't added a require statement over here that this needs to be staked first. But if I click on balance off, the number should update now, and yep, the number has updated. So how much is this number? So let me just copy this and paste it over here. Divide this by 10 to the power 18. So you can see that this is actually 0.06. So I have received 0.06 tokens in the whole time that I have staked my NFT. We can also check out these functions that are available for us. So token owner of 1, if we call, we get 0 because it is not present. We have deleted it during the unstake. Similarly, token staked at for 1 is again 0. We can do this for token ID 2, 3, whatever, but you understand, you get the gist of it. And this is basically how you create a small application, a small staking smart contract which can generate tokens for the user who stakes their NFTs. The biggest gotcha that I definitely am sure that you will run into is that you will forget approving the token smart contract to transfer your NFTs on your behalf. So just to do that, simple way is just go here, set approval for all, you enter the smart contracts address, approved true, and click transact. On the front end, the first request will be to this smart contract, to the NFT smart contract, where you will set approval for, you will send the message to set approval for all with the operator and the value. And then once that request succeeds, then you call the stake function from the ERC20 token smart contract. If the user is coming second time, first you check whether the user has approved your token smart contract to be an operator for your NFT smart contract. And to do that, just copy the token smart contract address and enter here. You open this is approved for all. In the operator, you enter the smart contract address, and in the owner, basically you enter your own address and then you call. All right, this will return true. If this returns true, then the user can stake. If it doesn't return true, then the user can't stake. Now let me just show you what happens if I am not approved. All right, so to remove the approval, I just need to call set approval for all with a false value. Okay, so I just click transact. Once the transaction succeeds, you can check that if I call this, it will return false. Now if I go and press 1 here for the token ID 1 and try to stake, you will see that I receive an error, and the error sort of looks like this. You will also see that the reason over here is ERC 721 transfer caller is not owner nor approved. So this generally means that you first need to get the approval on the NFT smart contract. Okay, once the approval is done, this will work just like I had shown earlier. Hope you like this video. I'm actually at my parents' place, so you can see the change in my background. If you like this video, please make sure to hit that like button. Subscribe to this channel if you haven't. If you want to send me any messages, if you want me to read something, please leave it in the comment, in the YouTube comment. If you have any specific question, please join my Discord server. There are a bunch of people just like you and me who are there helping each other out. If enough people comment on this video and like this video and ask me to create a follow-up, I will then basically have a chat in my Discord server and see what are the specific things you want to understand from this staking contract, and I will create a follow-up video on that as well. I hope to see you again next week. Till then, see you. Bye bye.